welcome back to our channel. So now, in week 3 and 4, Discrete Mathematics. Our lesson is predicate and quantifiers. Delve into the fascinating world of predicates and quantifier and logic by understanding what predicates are and how they are used to form quantifiers statement in Part A, Part B, and Part C. Okay, so predicates. What is predicates? A predicate is a statement that contains variable and become proposition when specific values are assigned to those variables. Predicates are commonly used in mathematics, computer science, and logic to express relationships or properties about objects or elements. Quantifiers. Quantifiers are used to specify the extent to which a predicate applies within given domain. There are two main quantifiers. First is the universal and existential. Universal quantifiers is like this sign, is used to express the predicate is true for every element in given domain. For example, universal quantifier x is greater than 0 means for all x is greater than 0. So this is true. Next, existential quantifiers. The existential quantifiers E like E, but this is symmetric in use to express that there exists at least one element in a given domain for which the predicate is true. For example, existential x is less than 0. So this means that there exists an x such as x is less than 0. And logically equivalence. Logically equivalence help us understanding the relationship between quantified statements. Two important equivalents are De Morgan's law and the distributed law for quantifiers. When using the universal quantifiers, we are making a statement about all elements in given set. For example, universal quantifiers x is greater than 0. This statement asserts that every element in x in the domain is greater than to 0. And existential quantifiers, we have example there that the existential quantifier x in all x is less than 0. This statement, it states that there is at least one element x in the domain that less than 0. Example 1. For a statement
universal
x plus 1 is greater than x, interruption for all real numbers x adding 1 to x result in number greater than x. The solution true because for any number x plus 1 is always greater than x. So remember, when we use the statement the universal quantifiers, it means that there is a true value for any real numbers. Example 2. The excess. In the statement, we can see that x squared is equal to 9. So there exists x for equal to 9. There exists real numbers x such as x squared equals to 9. Solutions true because x can be both 3 and negative 3, making the statement true. Example 3. The statement Example 3. The statement is logical universal x is greater than 5. Interpretation. It is not true that every real number x is greater than 5. Solution. True because there are real numbers that are less than or equal to 5. Example 3. Logical exists x is less than 0. Interpretation It is not true because there exists a real number x that is less than 0. Solution: true because there is no such real number. In this lesson, we explored predicates, quantifiers, and their logical equivalents. We learned how to express statements about sets, elements using universal and existential quantifiers, and we practiced solving examples to gain better understanding of these concepts. Predicates and quantifiers are fundamental in mathematical logic and computer science, and are used to make precise statement about objects and their properties within given domain. Thank you.